Hello everybody, so we're going to take a look at this problem. So in the pay it forward model, you start off with one person, they help three people, then each of those people helps three people. And when they ask, what can I do to pay you back? You just say pay it forward, help three people. That's what I'm doing. So let's make a mathematical model out of it. So at this point, we have one person, right? And then at this point we have three people. And then at this point we have 3, 6, 9 people. And then each of those is going to help 3, right? So what is the pattern here? So this is going to be 3 times 9, right? 3 times 9 would be 27. So how is this changing each time? It looks like from here to here, I multiply by 3, and then I multiply by 3, and I multiply by 3. Now what Trevor didn't say in the video is how we need to figure out the time it would take for one person to pay it forward, right? So let's just assume that we're going to deal with 1 week, because it is an important thing that you have to do to the person that they can't do for themselves. That's what Trevor said. So let's say it takes 1 week to pay it forward. So 1 week. At 1 week, 3 people are helped. At 2 weeks, 9 people are helped, and so on. So how many weeks will it take to reach 7 billion, right? Too many zeros there. So how many weeks, right? So I'm going to go ahead and put this in to GeoGebra and figure that out. What my equation is going to be is my function f of x is going to be 3, right? 3 times 3 times 3, and however many weeks it is, that's how many times I'm going to multiply by 3. So it's going to be 3 times itself that many times, so that would be to the power of the number of weeks. So it's 3 to the x. So I'm going to put that into GeoGebra and figure out when does x, what value of x gives me a value for 7 million. Okay, so I'm going to put in my function here, f of x equals 3. Now to do exponents, you do the up arrow, which is shift 6 on your keyboard, and it's 3 to the x power. Alright, so I have this graph showing up, and I want to get to 7 billion. So let's drag it, but let's see. Zooming out, zooming out. So billion is times 10 to the 9th. So there's 1 billion. There's 7 billion right there. So I'm going to say, I'm going to draw a line. How about g of x equals 7 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So this is the value, g of x equals 7 billion. And I want to find the intersection of these 2 points. Okay, so I zoomed in really close to find the intersection of these 2 points. And I'm just going to grab this point, and I'm going to estimate it here. Just grab something like that. Okay, and now I want to see what the value is. So I'm going to go to Object Properties and Show Label. I want it to be value. So it says 20.637 billion, and I just want to take a look at the numbers here. Let's turn on Spreadsheet. So I go to View, Spreadsheet, and over here I can put in, let's start with 20. So 20 is a little bit to the left of this. So what is it, how many people have been helped after 20 weeks, right? 20 weeks. So it's equals the function value f of 20. So I'm going to evaluate it at A1. And it says 3 billion people have been helped on the 20th week. Well, on the 21st week, 3 times that many, because every single one of these 3 billion is going to help another 3 people. So we're going to multiply this by 3. So the next day, or next week, function value evaluated at 21 would be 10 billion. So way more than the population of the Earth. So it wasn't a full year even. It was 20, half of the week into the 20th week, everyone on Earth had been helped. So it's pretty amazing the way that exponential growth works, and that's what we're going to talk about in this module.